Center for Research in Physics, BPF, Professor Ricardo Galvão. The Scientific Director of FAPERJ, the State Grant Agency in Rio de Janeiro, Dr. Gerson de Lima. Professor Piers Coleman, Coordinator of the School and Professor at Rutgers University. Professor Claudio Chamon, Coordinator of the School and Professor at Boston University. The Brazilian Coordinator, Elisa Barcetovich. The coordinator, Elisa Barcetovich, will give the welcome address.
Good morning to everybody. And so, Dr. Gerson de Lima, Scientific Director of FAPERJ, Professor Galvão, our Director, Piers and Claudio Chamon, our colleagues in this. So, ladies and gentlemen, good morning. So at this moment we are going to start with I2CAM, FAPERJ Spring School on Emergent Matter. And the topic is, as you know, new phenomena in high correlated quantum matter. This is expected to be a series, first of a series of three schools in complex and adaptive material, and to be held in Rio de Janeiro. When Piers Coleman and David Pine asked me to open a link for I2CAM in Brazil, I have tried to our CNPq, that's a kind of Brazilian National Science Foundation, and to our institute, but they both could not take this responsibility. You know, I2CAM has a fee to be paid and all everything. And then discussed with the director of FAPERJ. He understood the importance of this participation, and we have opened a link with a consortium of university and institutes in Rio de Janeiro. So, just to make the story short, everything seems to be working, and today we are here. So, I don't have the numbers here, I could not get, but I think the school is quite representative. Some people are still coming, and we'll have the students that are registered, and several senior scientists from the state, from Rio de Janeiro, will be coming to follow some of the lectures, participate in the discussion, discuss with you all. And the idea to have this kind of school, I think it's very important, because if you want to have collaboration in science at international level and focus in new topics like the complex and adaptive material, we should invest in the young people. I think it's very important that these people like you, and I see in the audience a very young face compared with conference we used to go. I think it's very important to bring you together, and the possibility to establish some collaboration between you and the Brazilian students. I think it's very important for the future of this field. And what we will expect from you in these days is that you learn about the topic, but you also enjoy the city where you are. That's one of the nicest cities in the world, I would tell. And I hope you'll be also prepared to come back here in August 2008 when we are going to organize this CAS in Rio de Janeiro. So I'm very glad to have all of you here. And of course I should thank you all the sponsors, that is the I2CAM, NSF, FAPERJ, and Canadian Institute of Advanced Research. And I should also mention our institute and CAPES. CAPES is a part of the Ministry of Science and Technology, and they gave a very, very important support to this school, more than I ever got for any meeting we have organized, and I think they understand the importance of a conference of this, a school of this level, and the international character that it has. So, thank you very much.
CBPF representative will give his address.
Good morning. It is a great honor for CBPF to host the first I2CAM FAPERJ Spring School on Emergent Method. The study of complex systems whose understanding cannot be summarized just from the comprehensive knowledge of their individual constituents is indeed one of the most relevant endeavors of modern scientific research. I sincerely hope that this meeting, focused on phenomena highly correlated to quantum matter, will mark the dawn of a fruitful collaboration between I2CAM, FAPERJ, CBPF, and other Brazilian institutions to promote the investigation of complex matter. Unfortunately, CBPF is going through a period of civil construction work and redeclaration, as you may have noticed. That makes it difficult for us to provide proper supporting infrastructure and accommodations for the participants. However, we will do our best to overcome these difficulties and offer you a pleasant stay among us. Please be all warm and welcome, and have a fruitful meeting. Thank you.
Professor Piers Coleman will give his address.
Good morning and welcome everybody. I believe that we have a representation here, possibly from every continent except from Antarctica. It's tremendous to see such a broad spectrum of people, South Americans, North Americans, but also Europeans, Asians, and I think there's someone from Oceania here. Let me say a few words first of all about I2CAM and I2CAM in this meeting. I2CAM is the acronym for the Institute for Complex Adaptive Matter. And this rather grandiose acronym really stands for a group of universities which originated in North America but now is spread out across the globe, who are committed to trying to find the organizing principles that govern collective behavior in matter. And I think it's worth just pausing a moment, just contemplating what that really means. Because for centuries, in fact millennia, science has been driven by the urge to understand the microscopics of nature, the smallest cogwheels that make it all work together, the idea of reductionism. And it is still a very powerful organizing principle and directive in science today. But as time has gone on, we've also realized that although we may understand the minutest cogwheels that describe science on its smaller scales, that we also need to understand how to put them back together again. And for example, if you like to think in terms of length scales, we probably understand physics fairly well on the scale of an angstrom and even quite well on the scale of a nanometer. But just contemplate what happens between the nanometer and the micron. At the scale of the nanometer, you have atoms or clusters of atoms that are essentially indistinguishable. Take a cluster of carbon atoms, of gold atoms, and of niobium atoms. Not so very different. But scale those clusters up by a factor of 100, and completely new things start to happen. The gold forms the lustrous, conducting metal that we all value so highly. The niobium, on a scale of about 100 nanometers, starts to look a little bit different to the gold. It starts to develop Cooper pair correlations. You're reaching the coherence length of the niobium superconductor. By the time you reach a micron, it's a full-fledged superconducting metal. And as for the carbon, well, carbon, of course, we know you can take it out to form bulk graphite or graphene, which is already very interesting. But mix it in with a few other atoms of hydrogen and oxygen. By the time you get out to a scale of no more than about 350 nanometers, it becomes possible to form the first microbes. So life already emerges between the nanometer and the micron. And whereas we're beginning to understand the emergent principles that govern superconductivity and the physics of cold quantum matter, we're very, very far away from understanding the principles that allow the micro, that allow life to emerge, already on a scale of 350 nanometers. And so I2CAM is devoted not just to hard condensed matter physics, but the full spectrum of physics, ranging from hard to soft matter physics out to biological matter. And it's part of the hope of this school that we will have a rotating sequence of schools on soft and biological matter in the next few years. I don't have much more to say about I2CAM, but I do want to mention that the brainchild of this particular meeting, alas, is not here today, and that's David Pines. David Pines, behind the scene, has been a constant source of energy, and if it wasn't for the fact that he came along to chat with myself and Claudia Shimon last summer and said, "Do you know," he said, that the March meeting next year happens to fall a week before spring break. He said, "You know what this means?" He said, "We can hold a meeting." Unfortunately, he regrets he can't be here today, but his eager eyes will be looking over this meeting, and in particular, that comes to the last point. This is not a conference. This is a school. Despite the fact that we started here off to a very bad start, sitting here in front of very formal microphones, the whole idea of this meeting is its informality. Each lecture contains 60 minutes of the formal lecture and 30 minutes devoted entirely to discussion. And we want that discussion to be interspersed within the body of the talk. And so the only way this can happen is if people start to ask questions. Okay? So loosen up and ask questions right from the very beginning. Shankar's a little bit worried that he may not get past the harmonic oscillator. We think they'll get a little bit further than that. But if he doesn't, it'll be time well spent. So thank you very much. I want to also finally thank Elisa and Claudio, but particularly Elisa. Elisa has an incredible passion for the field and amazing organizational skills. Yesterday I was at a museum where they had a number of ancient Greek statues, among which was the goddess Athena. And one of the things that defines the goddess Athena is her peculiar organizational skills. Okay, and Elisa is in this category, so I want to make a point. She's amazing. So that's all I have to say, but ask questions. Thank you.
The FAPERJ director, Dr. Gerson de Lima, will give his address.
Yes, well, first of all, I'd like to welcome everybody and good morning. Also, I'd like to congratulate Dr. Elisa for this organization and also the I2CAM representatives that are here. And I would like to add that in addition to this sense of organization, Elisa is very convincing. So she has talked to me about this school at least, I don't know, 50 times maybe. And the first time she talked to me, in fact, I said, Elisa, I'm already convinced because, in fact, I almost participated in I2CAM school in Switzerland. Unfortunately, I couldn't go because that was specifically in protein folding and misfolding. So a team that participated in this range of complex adaptive materials, and especially in the field of I'm a biochemist, medical doctor, but if you go to my house, you see a lot of books of quantum mechanics, everything. I'm trying to get some of it just by osmosis, but I would like to say that indeed we our funding agency, that it's a state funding agency, and that's not very common in Europe or in US, but in Brazil it's working quite well in a way that it's a regional funding agency that try to stimulate the specific interests of the science in that state or in that particular region. And particularly in the state of Rio de Janeiro, we have a very strong group, several groups, strong groups in many strong groups in physics, both in theory and experimental. I'm also an experimentalist, so I like more the empirical, but the theory I enjoy a lot. But also I participate as a biochemist and studying protein folding and using several of the new techniques, NMR and multiphoton spectroscopy, for example, fluorescence spectroscopy, to study protein folding. That's not an easy problem. Some people believe that's not. We learned that the best way to do that and to have people think about the problems in the area is with the small workshops, the small symposia, because that's the way to discuss. And as I mentioned also, I'm very sad that unfortunately I won't be able to stay for the program that is very good. I looked yesterday the internet, and I have a PhD student that is defending her thesis, so she'll be very upset if I'm not there. So in short, I would like again to say that I hope you have an incredible time here in Rio de Janeiro, and both by the side of the meeting and the workshop, and also by the trying to get some. I also found that there is not a lot of free time, because for people to go around and look Rio. But I hope you can this short time that short period that you have, you can go and visit the city that is. Some people say that it's one of the most beautiful cities in the world. I don't know if my friend here from São Paulo, I think he understood that because he's now here from the last 3 or 4 years, right? So anyway, so I wish a very enjoyable and very a meeting that can bring a lot of new collaborations in the future, and I hope that I2CAM can support and get together with FAPERJ to support the other meetings in this area. Okay, thank you.
Finalizing the opening of this meeting, the word is back to Dr. Elisa Bartz-Sakowicz.
Okay, so I just want to add very few points. First of all, this institute is a kind of national institute for physics in Brazil, belongs to the Ministry of Science and Technology, and has a tradition of having students from Latin America, Europe, and so on. So it's very open for collaboration. Maybe some of you would like to come to spend some time, because I think Piers forgot to say that I2CAM support exchange of students at this level between the links of United States institution and the others abroad. So, but if you don't like to stay at this institute, you can choose, because Rio de Janeiro has 4 universities that have groups of physics, very good ones. So there is plenty of opportunity in this sense. And the other point I would say that now that the school starts, I think the success of the school depends on you. So your participation and discussion, and that I think it's the most important point from here on, and that I hope you will not disappoint us. Thank you very much. Yeah?
We invite the members of the opening table to return to their seats at the audience in order to start the school program.
She forgot to say, because she was not informed, that peers will share this first session.